So now we're going to be talking about the difference between two proportions. So we're going to be doing the same process that we've done before, but this time we don't care about the average, we care about the difference proportions. So when we're trying to find a confidence interval for the difference between two populations proportions, we're going to be using this formula here. And if we want to get this critical z value, I've just given you a little reminder over here in that corner. So despite his inexperience, candidate A appears to have gained support among the electorate. 3 months ago, in a survey of 120 registered voters, 55 said that they would vote for candidate A. Today, 41 registered voters in a sample of 80 said they would vote for candidate A. Construct the 95% confidence interval for the difference between two population proportions. So let's go ahead and grab this formula here because this is what we're going to be using to determine this. And let's just make this a little bit smaller here. So this is all the data that we need. We need to grab all that data. So if we do, let's say, before and today, and let's say that, okay, so before and today, so P1, and I just want to let you know that I actually set this up a little bit different than the textbook. They do today and before, but it's okay. So before and today, so 3 months ago, we had a survey of 120 registered voters, and so the proportion of those that said they would vote was 55 out of 120, so that would be 0.4583. And today, they had a sample of 80, and the proportion was 41 out of 80, which is 0.5125. All right, and then we know that we're talking about a 95% confidence interval. And so maybe you know your z sub alpha over 2 or 0.05 over 2 or your z sub 0.025. That is a 1.96 critical value. So we actually have everything we need to construct this here. So we have 0.4583 minus 0.5125 plus or minus 1.96 times the square root of 0.4583, 1 minus 0.583 over 120 plus, and extend your square root bar if you need to, 0.5125, 1 minus 0.5125 all over, oops, look at that, that confused me there, 80. So calculate this super carefully. I would put this into the calculator, add them together, then square root them, then multiply them by 1.96. You may end up with some different rounding issues, but let's see how close we can get to each other here. So when you type that into your calculator, you should get something like 0.0021 plus 0.0050. And then when you do all that, you should get negative 0.05. And then 1652. So this is the confidence interval. You can also write it as two values in between. And there we go. So we're saying with 95% confidence, the percent change. So the percent change of support is going to be between negative 22% and 6%. 95% confidence, we can say that the percent change falls between those values. Okay, and the textbook sets it up a little bit differently. They pick a different P1 and P2, but it is okay. Go ahead and give this one a try. Press play when you're ready to see the solution. So we can use hypothesis testing with the confidence intervals. We're going to determine the null and alternative. We're going to construct the confidence interval like we just did, and then we're going to make a decision. We're going to reject if that difference value is not in the confidence interval. So this is really similar to our independent. We might set it up this way and then redo it this way so we can actually figure out what is that difference value. So revisiting example 2, or revisiting our previous example, example 1, we got the confidence interval of negative 0.2192 and 0.0598. That was our previous confidence interval. So we need to specify the competing hypothesis in order to determine whether the proportion of those who favor candidate A has changed over the 3-month period. So we're talking about if it has changed. So if it's changed, that means the original proportion is not going to be the same as the second proportion. And so we can rewrite that as it's going to not equal 0. There's going to be some sort of difference value. Oops, that should be equal to. And what we're interested in is this here is our claim. So we've got our confidence interval. So now is this value in the confidence interval? And it is. We go from negative to positive. And again, you can kind of think about it this way. We've got negative values and positive values. It does cover 0. So because it is 0 is in here, we do not reject the null. So we reject the claim. So there is insufficient evidence to support the claim that the proportion has changed. And here's the textbook. Now go ahead and do this one. You actually did the first part of this one before, so I've written your answer there, and then go ahead and give these a try. Press play when you're ready to see the solution. And then we're going to come back in our next video to do hypothesis testing without the confidence interval, but with the p-value approach.